Okay, welcome to this video everybody. We are continuing to talk about groups of elements, and we've talked about the group 1 alkali metals, everything about them. And now we're going to move on to the next group, not group 2, but group number 7. Let's go and have a look at group number 7. So here we go. We're talking about the halogens. This is the sort of name that we give them, just like alkali metals is group 1. This is group number 7, and here they are: fluorine, chlorine, bromine, iodine, astatine, and tennessine. I don't even know how to say that last one. Don't worry about it. Cool. So the word halogen, I thought I'd go and tell you what it actually means. It means salt maker. So basically, any one of these elements that will react with most of the metals, remember left hand side, to form salts. So that's basically why they are called the halogens. So let's go look at some classic ones. Like we've got the very common ones here is chlorine, bromine, and iodine. Okay, check it out, check it out, check it out. So these are the colors. Like, what color would you say this chlorine is? Come on, say it to me. Beautiful, like pale yellow, right? I've even seen some people call this like pale yellow slash sort of greenish yellow. Okay, this is sort of dark brown. This is the bromine. Beautiful. And yeah, if we had to take room temperature, okay, and we had to look at the state and the color, well, of course chlorine would be then a, yes, you've guessed it, a gas. What about bromine? Come on, have a look at it. Gas, genius. And this last one here is iodine, and interestingly it is a solid, and it is actually this black solid. And for those that take biology, you will see iodine in its liquid form is also quite a brownish color, but in its solid form it is black. So that's the state and the color of some of the most common halogens. Beautiful. So let's go and just talk about a few more things. So let's take chlorine. It's such a common one to use. We know that there are 7 electrons in the outermost shell, not in total, right? In total on the periodic table, you'll see the total amount of electrons is 17. Let's just double check that. Oh, nailed it. 17, and its relative atomic mass is 35.5. Beautiful. So you count up all the electrons, you draw your nice little map, and the outer ones I've drawn over here, and you can see they are 7. So they just need one more space to actually fill and complete their outer shell, to complete sort of the 8 octet rule. So they only need one more, and this is the reason why they are very, very reactive elements. Okay, so let's have a look at reactivity quickly. Let's take a look at fluorine and chlorine. So let's say fluorine over here, it's got 9 electrons, and chlorine we said had 17. So let's quickly just go ahead and draw this. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the different shells. That's the first shell, and this is the second shell over here. Beautiful. Okay, let's look at I'm just going to draw these electrons a little bit bigger, because I know there's some people out there like me that are just like, sir, please just draw them better. Okay, so I'm going to do that now. There we go. Beautiful. So now if we had to do chlorine, check this out. 1, 2, 3, 4, 5, 6, 7, 8. Count with me. 9, 10, 11, 12, 13, 14, 15, 16, 17. First shell. Try and draw those shells lines quite lightly. Second shell and third shell. There you go. We've got that empty space over there. Now, you might ask yourself the question, which one's more reactive? Is fluorine or chlorine more reactive? Well, let's quickly just consult the periodic table. Always consult the periodic table. So if we look at fluorine and chlorine, they're kind of sort of, fluorine is at the top and chlorine is at the bottom. So does the reactivity go downwards? In other words, does the reactivity increase as you go downwards, reactivity, or does it increase as you go upwards? Well, I always try to tell my students it's better to understand it rather than just go and learn it. So let's go and understand this now. Okay, so we know, of I've lost my mouse. There it is. Oh goodness, I can't see my mouse. This is so weird. Okay, it doesn't matter. I've made my way. Now, remember, we have this concept. I can't, for the life of you, tell you why I can't see my mouse. It doesn't matter. Okay, so we've got this idea that we have a very positive nucleus for both of these elements, right? And this is because of the protons inside that nucleus with the neutrons, which are neutrally charged. Now, if you think about it, this electron, okay, that is in the outermost shell that needs to be filled, right? This incoming electron, it's going to come from a metal like sodium, for example. Here it comes. I'm going to draw it with a little plus sign. Okay, so we take this, oopsie, take this. That in comes like this, right? It's incoming. It is further from the nucleus. If we had to draw a sort of distance thing here, it's further from the nucleus than it is for fluorine. Okay, let's say we had the same electron from sodium coming along and joining here. That's quite close, right? We say that because the distance is closer in the fluorine than with the chlorine, it means that it's got a stronger pull, it's got a stronger force of attraction to the nucleus. So it's much more likely that if you had an electron just sort of waiting to be pulled, it's much more likely that fluorine is going to pick up that electron, because it's obviously, it doesn't have that many shells to get through to get to this positive nucleus. So it's because of this positive nucleus that the electron is actually flying in to fill this last spot. Now, if you've got a whole bunch of shells, it's much further apart than that. So it's if we had to say which one is more reactive, we would say that fluorine is more reactive than chlorine, whatever, than chlorine. And it's because of this idea of the distance. So let's just read it through together and see if it makes sense. As the atom gains more shells, so chlorine has more shells, an incoming electron is further from the nucleus, and the incoming electron is shielded from the attractive force of the positive nucleus. In other words, like there's more distance between the positive nucleus and this incoming electron. Therefore, it won't happen that easily if there's just a whole bunch of these shells. So if you have a look at the periodic table one more time, you actually are going to, if you go upwards like this, the reactivity is going to get more and more and more. So fluorine will be more reactive than chlorine, or chlorine will be more reactive than bromine. Okay, let's leave it there for now, and I'll see you in the next video.